Hello. If you want to let me know any questions that you have first, I'll be here in 4 minutes and then I will go through anything that you have. There shouldn't be too much going on today, but just let me know. Question 7. Year 7. This one. Do that right. Looks like quite a complicated question. Um, okay, give the formula for propane is the first question. So, what you're supposed to know on this is that as you go down here, there's a little bit of a pattern where the number of H's is always, it follows a pattern for the number of two. It's like a sequence where if you see the number of H's, they're actually going up by two every time, and the number of carbons is going up by one every time. So there's one there, then there's two there, so there must be three here, and there'll be eight there. So that is what propane is. And then it says, so that's that one. What happened to the boiling point of alkanes? These are called alkanes, these things. Um, as the relative formula mass increases, so the relative formula mass is going up. What's happening to this number, or these numbers? They are increasing. And then draw a graph, plot the points, and draw a line to best fit. Um, okay, so we've got a graph here for relative formula mass and boiling point. So relative formula mass is 16, boiling point minus 160. All right, now we need a horizontal scale. No, we haven't. So 16 is about, I'll do it very roughly. Um, 16 is minus 160. Okay, so is it going up by 2, 4, 6, 8, 10? Yeah, 12, 14. So that's there for minus 160. And then 30 is minus 90. 30 will be about, oh God, 30. So that'll be minus 100. So minus 90 is in the middle of that. So it's going to be about there. And then 44 minus 40. Minus 40 is there. 40 is there. That'll be about there. Can't do the next one because there's a gap here. And then 72, 36. 72 is about there. I'm doing it quite roughly here. It's about there. And then 86 and 68. It'll be about there somewhere. And then it says draw a line of best fit. So you'll just draw a line that goes like that through there. And then what is the boiling point of butane? So butane has a relative formula mass of 58. So what you're supposed to do now is go to 58 on this axis, which is going to be about 2, 4, 6, 2, 58 is about there. And then you go up from there until you hit your line and then read across, and that will be your answer. So I'm going to just put 0. That seems to be about right if you follow the pattern. So yes, I'm doing number 7 at the moment, so that will be done in a second. Oh, I've got to turn this on. I need to do that. Um, okay. Um, Show clearly on the graph how you found it, done that. Circle which of the following is not an alkane. So alkanes have this formula where this number here is always, to get to this number here, the H number, you double this number and then add 2 to it. So if that was 5, you double it and add 2, and you get 12. Take any other number, like that one, double it and add 2, and you get that one. So it's only when it doesn't follow that pattern that it's not an alkane. So you see this one, doesn't follow that pattern because it's just doubling. It's not doubling and then adding 2. All the others double 14 and then add 2, 16. Double 11, 22, add 2, 24. They double and add 2. So that's what that is. Right, that's number 7. I'll go back then to number 2, 3, 4, 5, 6. I might not do every question if I feel that you should be able to do it. Right, this one. What makes nitrogen and oxygen react during thunderstorms? Right, during a thunderstorm, it gets very hot when the lightning strikes. So it is the high temperature. So when it suddenly, have I missed a question out? 2A. No, I haven't. Yeah, so the high temperature from the lightning striking is what we're after here. Complete the word equation for nitrogen and oxygen. So nitrogen and oxygen react together and it makes something called nitrogen oxide. And then in an endothermic reaction, okay, it's quite hard to explain this, but I will try to explain. In any chemical reaction, what happens is that what we have to do is all the things on the left, what we have to do is take in energy to break them up into little pieces. And then what we do is we make new things with them on the right-hand side. When we make new things, it releases energy. So energy is taken in on the left-hand side to break things, and energy is released on the right-hand side to make the new stuff. Now, if this, what we're taking in is bigger than what goes out there, we call it an endothermic reaction. So in an endothermic reaction, the energy needed to break existing bonds is more than the energy released. That makes it an endothermic. What's taken in is more than what goes out. Um, Quite complicated questions these for you guys. But the energy that represents the activation energy is like the energy you need to get a reaction started at the beginning. And to get a reaction started at the beginning, um, you have to sort of, it's like striking a match. You have to start off by increasing the energy, and that's what this increase is. So you see that A, it has to go up first and before it starts coming down. So that is activation energy, which energy shows that the reaction is endothermic. So this arrow here is showing that what we started with has gone up and finished there. So we have increased energy. That's why that is that one. Okay, question three. Hmm. So there's a reaction here between these two things. We've got some bubbles, and it's exothermic. An exothermic reaction is one where we release or give out heat energy. So what measurements could you make to show that it's exothermic? Well, if you measured the temperature of this before and then measured it later after you did the experiment, it would be hotter because it's given out energy. So what measurements would you take? You'd measure the temperature before at the beginning and then temperature at the end. The 2 marks is for that. And that's it. How would they show that the reaction is exothermic? The temperature at the end should be higher, right? Because it's gone up. We've given out heat. It's like starting a fire. Okay, that is two. Um, so now we investigated how changing the concentration affects this reaction. So what we're doing in all these different test tubes, we're putting in a different concentration. Concentration is like how strong the acid is. So we're trying it with a weaker one, then a stronger one, then a bit of a stronger one, then a bit of a strong one, whatever, different strengths. A control variable, though, is something you should keep the same. And an example of something you should keep the same here for all of them is their temperature, or starting temperature, I think I'm going to put, because we're not checking how the temperature affects it, we're checking how the concentration affects it. So that would be a sensible answer. Which test has the greatest concentration? Now, if we have a big concentration, I would expect to see more bubbles. So you see that one there, that seems to have the most bubbles. So I would say that would be B. Why did you choose this test tube? Because it has the most bubbles. Um, And the student predicted that if the temperature was increased, the reaction would take place faster. Any chemical reaction takes place faster if you make it hotter. And that is because all the little particles that you can't see move around faster. That's one. Must be another mark here. And because they move around faster, they hit each other more often. So you see, if you've got all of these and all of these inside a container, then if they're moving around faster, they'll hit each other more. And if they hit each other more, they're more likely to react together. That's what the rate is. Which of these items uses an endothermic reaction? That is a sports injury pack. Let me explain what that means. Sometimes inside a first aid kit, you have this pouch that if you shake it, it gets cold. Because sometimes you need to put ice on somebody that's doing hits, like been hurt, and you might not have ice available to you. And so you have this thing where if you shake it, what it does is it sucks in heat energy from this gel around it, which makes the gel cold, and then it's there. So that uses an endothermic reaction. Um, but that's the same thing again. The activation energy, like I said, is when you see one of these graphs. Again, you'll get used to this. But when you see one of these graphs, the bit that goes up to start with is called activation energy. And then the overall energy change is always from here, where it started, to here, where it finished. So it's this arrow over here. Complete the sentences. In an exothermic reaction, the energy of the product. So if you haven't, in an exothermic reaction, the energy of the product is, so let me try and explain that better. This line here shows you the energy of the products there. This shows you the energy of the reactants. That's what you start with. And that you see is lower or less than that, that's what makes it an exothermic reaction. Name an apparatus used to measure temperature. I mean, I shouldn't need to write this down, but I will. Thermometer. This shows the temperature at the end of the reaction. Use figure 2 to complete the table. Right, this shows the end of the reaction. So when it says temperature at the end, you have to read off what this number is. What is that number? So it's 26, 27, 28, 29, 30. So that looks like 27 and a half to me. So I'm going to put that there. And then the change in temperature is the difference between these two numbers, which you are welcome to use a calculator for, but without one. Um, 27.5 take away 14.3 is the change, and it's 13.2. Question 5. Potassium reacts violently with cold water. In what physical state is hydrogen given off? Hydrogen is usually given off as a gas, so that would be that. What type of substance will neutralize potassium hydroxide? Potassium hydroxide, as it tells you in the question, actually is an alkali. So what do we need to neutralize an alkali? An acid. What is the pH of neutral solution? Your pH scale tells you that 7 is a neutral pH. In the periodic table, there are 8 main groups. What is the number of the group that has potassium in it? I'll just tell you it is in the first one. Um, Sodium is in the same group. How does sodium react with cold water and what is formed? Well, we learned what happens when sodium reacts with water. Sorry, when potassium reacts with water. Now, because sodium's in the same group as potassium, it basically does the same thing. So it reacts violently with cold water, and this time it will make not potassium hydroxide, but sodium hydroxide and hydrogen. So violently, I'm going to put. And what is formed, I'm going to put sodium hydroxide and hydrogen. You're just using the previous information to work this out. How can you prove that an alkaline solution is formed? Well, how can you check that something is an alkaline solution? You could use something called universal indicator, um, or you could check the pH. Let me see what the mark scheme says here. Um, yeah, add universal indicator, and it should. Universal indicator is used to check whether something is an acid or an alkali. In an alkali, it sort of turns blue or purple. Okay, so it should turn blue or purple. Right, that is question 5. 6. Crude oil and natural gas are mixtures of hydrocarbons. They are obtained from wells drilled into rocks. What is the name of the process used to separate, right? This thing is called fractional distillation. It's this process that we use to separate all of the things inside the oil that we get out of the ground. Um, Methane is one of the gases. Give another Give them another hydrocarbon gas. Ethane probably is an answer. These things are just there's lots of different names that all end with ane. Um, yeah, ethane. I'm going to put, and we could have had all that table at the beginning in the first question had loads of them. If you remember. Complete combustion for of methane. Complete combustion is a burning. It's basically all it means burning. And when you burn something, the products are carbon dioxide and water. And the different gases produced by incomplete combustion. So just so you know the difference between these two. Complete combustion happens when you have lots of oxygen. When you don't have much oxygen, you get incomplete combustion and you make something called carbon monoxide, which is a little bit dangerous. So that's that. Question 7, I did. And then 8 has also been asked, and that'll be the last one, I guess. So again, I shouldn't need to do this really, but protons are there. The other thing inside the nucleus is called a neutron, and the things going around the outside are called electrons. The rest of this might be a bit harder. The mass number is always the bigger number on the periodic table. So in this case, it's number 13. And remember, this number tells you that it's got 6 protons and also 6 electrons. Protons are positively charged, electrons are negatively charged. So because there's the same number of both of these things, they kind of cancel each other out. So that's why when it says atoms of carbon have no overall charge, it's because the number of protons is the same as the number of electrons. And then this will be a bit harder. Butane, which is this thing here, is a hydrocarbon. Oh, it's not an option. Compound is the option. The compound is just chemicals joined together, like that. It contains carbon and hydrogen, and each of those lines represents a chemical bond. It's actually a covalent chemical bond. The correct formula for butane, which is just counting now, isn't it? So it's four of these, so C4, and then how many H's there are, which is 10. So it's C4H10. And that is all of that booklet, basically, isn't it? I've just done all of it. Fine, that is all. I'm fine. I'm okay to do that. Just so you all know, because there's only a few of you here, but we're going to do these sessions for another week, and then next week will be the last one we'll do, because then you'll have like some tests and stuff in July. So we won't be setting much homework and stuff at that point. So there won't be any of these, and then there's only two more. Um, Lessons in July, basically, at the end before we close for the holidays. Right, that is everything I've answered there. If you have any more, I will check back here in a bit because I've got to be here for the year 10s as well. Um, but if you have any more questions from your respective booklets, yes. I wasn't even doing the booklet from booklet one, so I wasn't doing any of those ones. Um, so if you have any questions from your booklet, within reason, then I will have a go at answering some of them, which will have been this one, wasn't it? It was booklet two. I haven't done anything from booklet two yet. Well, I have, in the sense that some of them are the same questions. A lot of them are the same questions, actually. In fact, are they all the same questions? Yes, they are. So it's fine. There's a recording of it, so you will be able to get that anyway. Um, yeah, it's the same booklet. So I have answered basically all of those questions in the thing I've just done, which was here, because I think booklet one and two were the same this time. Um, So yeah, so there is a recording of that. Well, hopefully there's a recording of that, or I can send it to you if necessary. But these were the answers. What I'll do is I'll just because I think this is I might have started recording a bit late, but I can just kind of do this, and then you will be able to see it. Um, on our YouTube page. So every week I send an email about this lesson. So you'll have hundreds of them over the last year, and all of them have a link to the YouTube page which has things on it. But if you have any problems, just all you need to do is the people I teach, and particularly, you can just at the beginning of the lesson, just we'll go through it quickly. It's fine, so don't worry about it too much. You can always go through it at the beginning of the lesson. It's sometimes harder with some of the others because they have a routine to follow, but we can just talk about it at the beginning of the lesson when you come on Sunday. Right, fine. I want to go and then I'll be back in 20 minutes because there will be possibly some year 10 questions. So, if anybody briefly has any more questions on their homework, I've been through basically all of booklet one and booklet two, so that will be have been recorded. It's just if there's anything on booklet three that I will go through now. I know one of you has just joined, but if you need anything from booklet one or booklet two, it will have been on a recording, most of it, um, on the YouTube afterwards. So you can get it from there if you need it. I did the whole thing basically for one and two. Mhm. So if you have any, I've done one and two have been done. If you have anything from booklet two, sorry, booklet three, then I will can do some of it. I have a little bit of time to do some of it, but I won't be able to probably not do everything. I appreciate it might be quite challenging. But is there anything in particular from booklet three that anybody would like me to go through? Three ABC, excellent. All right, let's have a look at three. So, question three says cars cause atmospheric pollution. Some car emissions contain nitrogen dioxide. The table below shows the concentration of nitrogen dioxide in air in three different areas for a week. So, city centre on Monday to Sunday, this is the amount. Countryside, much less. Motorway, some. Which column of data has the greatest range? Now, what is range from maths? You may remember range is highest takeaway lowest. So for the city centre, what's the highest number? It looks like 37 to me. Um, and then the lowest of these numbers is 22. 37 take away 22 is 15. Okay, you've got to do that for all of them. So for the countryside, the highest is 8 and the lowest is 6. So the range is 2. For the motorway, the highest is 23 and the lowest is 17, which means the range is 6. The question is, which has the greatest range? So isn't that the city centre for that reason? Explain why it is lower on a Sunday. So look, it tells you in the question that cars cause this pollution. So what do you know about Sundays? Right? Sundays generally have there's fewer cars on the road because there's fewer people possibly going to work or whatever it might be. And if there's fewer cars on the road, there'll be less pollution from the roads. So you'd say less traffic because there's no school or less people go to work or something like that. So three, four, five. I'm not doing any more than three, four, and five, just so you know. You'll stop there. Um, Calculate the mean value for the concentration of nitrogen dioxide from Monday to Friday. Okay, I'm not going to do this. I'm going to tell you how to do it. So, um, Monday to Friday, the mean um, for the city centre. So, city centre mean Monday to Friday. So, what you have to do is add up these numbers and then divide the answer by 5. That is how you calculate the mean. Um, from there, that's it. Nitrogen dioxide is removed from car emissions by catalytic converters. Which two of the following are correct statements about catalysts? What do you know about catalysts? Catalysts are something that speed up a chemical reaction. And they do that by doing this thing here. It's a bit technical, but they lower the activation energy of a reaction. Yeah, it always is. Again, the same link. You have to find it in the email on our YouTube, which is always the same. It should be going on there. It will end up there afterwards. Um, Pretty sure it's going on there right now. Yes, it is. Um, Hopefully. Um, you're going to get banned from YouTube, aren't you, soon enough, you guys? That'll be interesting. Um, and then the other answer is the catalysts are not used up in a reaction. That's that. Um, the catalyst in a catalytic converter contains platinum. Platinum is an unreactive metal. Platinum is a must be a finite resource. It must be. The answer finite means it will run out at some point. So I think it's that. Okay. The test for carbon dioxide, again, you're going to have to learn these as quickly as possible. There is a test for carbon dioxide which involves lime water that you add it to. And then for hydrogen, there is a test that involves a burning splint. And for oxygen, there is a test that involves a glowing splint, which is obviously not for this question, but for a different question, it would be. Um, and then you also said 4ADE. Three improvements to make this more accurate. Right, so I'm not going to read this because I've read it before, but the what we're doing here is we're measuring temperature. Generally, if you're measuring temperature in a reaction, you don't want to use a metal container. So because a metal container lets the heat out really easily, and so your thermometer won't pick it up as easily. So you can use something like a polystyrene cup, like the cups that we use for coffee. They keep the heat in a bit better. That's one thing. Also, if you're doing a temperature reaction, you want to put a lid on it to prevent the heat escaping. And also, this thermometer is one of these old style traditional thermometers. There are better thermometers than this. There are digital thermometers, which give you a more accurate reading. It's quite hard to read these sometimes, but a digital thermometer is more precise. Okay. And then I'll let you read that because that should be quite easy. Yeah, you said D and E, didn't you? Um, D, determine the gradient of the line. Okay, again, I'm going to tell you how to do this because it does tell you how to do this. For this line, all you need to do is measure the increase in temperature. So measure this distance here using the axis. Now that looks like 50 to me. It goes from here to there, which is up to 50, right? So that's 50. And then measure the increase in mass, which is this way. How big is that? Well, 6, according to the axis. So you end up doing 50 divided by 6, and that should be your answer. And why should you not use more than 10 grams of zinc? See, what this graph is showing you is that if you use this much zinc, that's the temperature increase. If you use this much increase, it's that much increase. But if you continued this line for 10 grams of zinc, the temperature increase would be really hot to the point where it might be dangerously hot. And so you should extend the graph line. You've done that. And you should explain that it would get too hot because the temperature increase would be like 80, 90 degrees if you did it with that much zinc, which could be dangerous, and you could get burnt. Booklet two, I've already done all of it, so you can go back and watch the thing on it, because there is a recording on all of the emails that I sent to you. So I've done all of booklet one and booklet two, literally completed it. We just have to go back and watch it. Um, Five, part two, four, and five. Um, Right. When you see these kind of graphs, just get used to this, right? Which is if you see a graph that goes sort of up, then down and finishes lower, it is an exothermic reaction. Whereas if the graph finishes higher, like that, then it's an endothermic reaction. It shouldn't make this quite easy, really. The activation energy is always how much it's gone up by, so it's there. And the type of reaction, again, as I said, because it's gone up, then finished lower, it is an exothermic reaction. And the reason is because the energy of the product is lower than the energy of the reactants. And then calculate the value of B. So it's just going to be that take away that, right? So it's going to be the this number take away this number. It's just using the lines on the graph, so you just work that out and you should be fine. Um, is that it? 5, 2, 4, and 5. Okay, I don't know what else you asked. Maybe this one. Um, I'm just going to say this because yeah, it's quite a hard question, that last one. But what is the relationship between the number of carbon atoms? So you need to say that as the number of carbon atoms increases, the heat energy released. Um, well, it increases. Oh God, it increases up to there. How do you answer this? Okay, it should be that it increases. Um, so as the number of carbon atoms increases, the heat given out increases. Fine. So it's just all you need to say is as that increases, even though there's a slight problem in this table. Um, and then the last one, um, the value in the data book for the amount of heat energy 1 gram of butanol is burned. Butanol is there, is actually 36.2. Give two reasons why this might is looks wrong. I mean, that number should have been like bigger. Okay. There could be because when they did the reaction, you see here, this goes back to that thing. When you're measuring temperature, you need to put a lid on it. And also, you don't want to use a beaker. You want to use like a polystyrene cup. So they should have put a lid on it, and that could have affected their results if because they didn't. And also, you could mention that there's no insulation because the beaker is not good for that kind of thing. I'm just going to tell you this because you wouldn't be expected to know this, but the answer is that for this one. Right, okay, fine. That is enough for that bit of it. Just as a reminder for those of you that weren't here earlier, the next week will be the last one of these that we do. After that, we won't do any in July. You'll have 2 lessons in July until the schools close and we close for the summer. And then yeah, you also have a, for those of you that are here, I think not everybody's going to be here in July, but there is a test at the beginning of July as well, which I will contact you about later. Um, right, that's it. I'm going to come back in 10 minutes in case anybody here 10 joins. Hello. Right, for the year 10s, the few of you, I'm sure. If you have any questions from the homework, then let me know. I will keep it brief today. Just to let you know again that this next week will be the last one of these that we do, and then we won't do any in July. There's 2 weeks in July before the schools close. We won't have any then, and because you'll have a test as well, so there won't be any homework we're going to set. Any questions from this? It's not. I don't know how difficult or easy this was. Hmm. I'll probably just start going through some of the questions actually. But if you have any specifics, then just ask me. I'll run through some of these. I might not do the first one. Let me see the shorter ones. This is a very important question to be able to do, which is how does temperature increase the rate of a chemical reaction? Generally, people have an idea about how to answer this, but they might not do it perfectly. Um, so you want to say, firstly, how does temperature affect the rate of the reaction? You want to explain that the rate increases. Rate means how quickly it happens. But why does it increase? It's because when you increase the temperature, the particles gain energy. Um, and if they gain more energy, they move faster. And if they move around faster inside the beaker, there are more frequent collisions. You need to mention that word, that phrase exactly like that. Not just more collisions, but more frequent collisions is really what you want to say. 4A and 3B, I shall do that. 3B. Um, I did this earlier 'cause it was in the other one. Explain why the nitrogen dioxide in the air is lower on a Sunday. So look, they tell you in the question that nitrogen dioxide is or is emitted from cars. What do you know about cars on the roads on a Sunday? Um, you should know that generally on Sunday there are fewer cars on the road on Sundays. Why? Because there's no school, people don't really go to work as much on a Sunday, that kind of thing. And as a result of that, the numbers for Saturday and Sunday are lower than they are for the rest of the week. So you generally have fewer cars on the road. So it's more of a common sense type thing, like than a chemistry thing. Um, for a 3B, okay. Three improvements to this investigation. Okay, so this wasn't the same in the Key Stage 3 homework as well, but um, any investigation where you are investigating temperature, right? It is important to do a few specific things every time. So if you're measuring the temperature, let's say during a chemical reaction, right, with this thermometer, it is important that it picks up all of the heat that is being produced. Now, if you do this in a metal container, metals are very good conductors of heat. So imagine all the heat that's being produced here. A lot of it will go out of the container, and this thermometer won't pick it up. So you don't really want to do any temperature related investigation in chemistry in a metal container, even a glass beaker. What you want to do, ideally, is use a polystyrene cup, like one of those cups that we drink coffee out of, because they generally are slightly better at keeping the heat in. What you want to do is have like an insulator here, so all of the heat stays in here, and then this thermometer will pick it up, and you'll be able to read the temperature more accurately, and you won't be lost to the sides. The other thing that you would like to do is what if all of the heat from here goes out like that? Then this thermometer again won't pick it up, and so your results won't be very accurate. So ideally, what you want to do is make sure you put a lid on any container when you are investigating temperature. That's another improvement you could make to this investigation. And lastly, what I would say is this thermometer itself. This is one of those old school traditional thermometers where you have like some mercury rising up here and you have to read off it. That is not the best way to read temperature from a thermometer. You can have better thermometers like digital thermometers because they give you the exact number and the exact reading and it's more precise. That would be three improvements that come to mind as I look at that. Is there anything else? Let me just check what it says in the mark scheme. So polystyrene cup, lid, um, digital thermometer. You could also stir it. That might make it a bit better because you'd get the reaction happening better. Um, and yeah, that would be it. Right, 2B and D. Let's have a look at that. So, let me read this. Workers were forced to flee a factory after a chemical alert. The building was evacuated when a toxic gas filled the factory. It happened when nitric acid spilled on the floor and mixed with magnesium metal powder. Um, Give the formula of the toxic gas produced. Well, it must be this, right? So NO2, if you put the 2 in front of it, should be fine. But the products are there, and the only one of those that's a gas is there. Explain in terms of particles how the toxic gas was able to fill the factory so quickly. Well, I think this is something to do with gases, right? What do you know about solids, liquids, and gases? The particles in a gas move, firstly, they're not still as they are in a solid. And you don't want to say they spread out, but you can say that they um, diffuse. I think the diffusion might be the best answer here. Um, and so they diffuse and fill the factory. So look, if this is your factory and this accident happens here and it produces this gas, what do you know about gases? They diffuse from a high to a low concentration. So they kind of move and they fill the whole factory very quickly. So that is that. The other question, D. Um, Water was sprayed. Why does that slow the reaction down? Well, it's the opposite of what I said before. If you spray water on a chemical reaction, it lowers the temperature, cools it all down. If you lower the temperature, the particles move slower, because they have less energy, and there's less frequent collisions or fewer collisions. And the collisions are the things that make the reaction happen. So if there's fewer of them, the reaction is not happening quite so quickly. Okay, is that everything? I won't keep everybody here if you don't have any other specific questions. But is there anything else in here that sticks in my mind? Um, Again, just as a repeat, this will be the penultimate one of these that we do. So I'll do one more next week for the homework that you have this weekend, and then we won't have another one because you have a test at the beginning of July and you'll have a lesson going through the test as well. So there won't be any homework at that point that we will set. So there won't be any of these. Just lastly on this, I'm just going to do this, which is the test for carbon dioxide involves lime water. Lime water turns from colorless to cloudy when you put carbon dioxide into it. If you can learn these things now, it really saves you some effort later on. The test for hydrogen involves a burning splint, and you'll hear a squeaky pop. You may have seen that before. The test for oxygen involves a glowing splint, as in you light it, then blow it out, and it glows, and then it relights when we put oxygen into it. These tests for gases are um, important to know because it just makes your life much easier. Right. Assuming there are no further questions on any of the homework, I am not going to do any more for today. Remember, if you do have a question, well, I mean, it's only got one left now, but we'll talk about it more in terms of if you are with us next year as to how these sessions run. We might in future ask you to send some of the questions that you're stuck with on our WhatsApp beforehand. So that we have them to do beforehand. But that's something we'll chat about next year. Right, that's all I'm going to do then for today, given that there are no further questions and very few of you here. So that's it. I'll see you later.